dive into 9-2. Now, I forget if I talked briefly in this class or if I just did it in the afternoon class, but there's a big difference to pay attention to when we deal with inequalities, and we will see that once we deal with negative values. So our superstar runner, I forget his name, Johnny I think it was, says, you can double my time and I will still be faster than yours. And their time is 94 seconds. Now Johnny's insanely fast. He's like one of those, you ever heard of a prodigy? A prodigy is like somebody who was like born to do something. Like it said, like Mozart and Bach and those guys, they were musical prodigies. They were born for music. There's some people who are like, any kind of prodigy. Anyone who you look at them and you're like, wow, they're really good at that. So Johnny's a running prodigy. So we don't know what Johnny's time is, but we can figure it out. He says, you can double my time and I will still be faster. Like my time doubled will be faster than that 94 seconds. How could I write that as an inequality? This is not on your notes. We just want to turn our brain on for how we're writing inequalities. Bunger? 2x is less than 94. So it says the superstar succeeds 3 times and fails the 4th. So on the 4th time, his time doubled, was not faster. But Bunger correctly identified it. It is faster. It is less than. So my 2x is less than 94 because, again, how do we remember the inequality? The alligator. The alligator always wants to eat the bigger value. So how do I solve for x here? Layla, what do you think? How do I solve for x? I would divide each side by 2. Break this up. What's 90 divided by 2? 45. And then 4 divided by 2 gives us, an extra 2 more. So that means that x must be less than 47. So what could have been his times on run 1, run 2, and run 3, the runs where he was successful? What are 3 possible okay times? 43. Sure, it's less than 47. 30. Whoa, that'd be insanely fast.
21.
I'm going to throw a question out there. What about 47? Would that work? No, because we don't have the or equal. So we could do 46, but the 4th time when he doesn't make it happen could be 47, could be 48, 49, 50, could be anything above that, at that 47 or above, because that would be failing. 47 is not less than 47. It's equal to. Yeah. Anything equal to or greater than 47. So if his time is greater than or equal to 47, it's a fail. If his time is less than 47, it's a win. Questions on that one? Johnny's real fast. He's insanely fast. He's probably like 6'5" and only weighs like 140 pounds. He's a stick skinny guy with crazy good running muscles. All right, so now diving into our notes. The big thing in here is when we have an inequality and we divide, it still stays true.
The multiplication property of inequality for multiplying by a positive number states that if you multiply each side of an inequality by the same positive...
So that it stops talking. If you're watching the video, hopefully that worked. So think of an inequality. And we set up an inequality. We see the algebraic method. But so -5 is less than 10. Do you agree with that? That -5 is less than 10? Yeah. If I plot these on the number line, -5 is here, 10 is there. I know anything to the left is less than. So there's my points plotted on the number line. Now what would happen if I doubled both those values? How would they travel? Isaiah, what do you think? The -5, be careful, we gotta say the negative. The 10 would go to the right, the -5 would go to the left. I agree, because when we do something to a quantity, like when we multiply, it's getting further away from 0. When we divide, most of the time, it's getting closer to 0. but they still stay to the left or to the right, wherever they are. So if we multiply by 3, negative 5 will go 3 times further away from 0 to the left. Positive 10 will go 3 times further away from 0 to the right. And my inequality stays true because negative 15 is less than 30. So the multiplication property of inequality is the same as the multiplication property of equality. If I multiply on both sides, my expression stays true. My inequality stays true. Same thing with our division property. Sorry, I want to back up and capture this real fast. Think about two values that we could use to represent our division property. So you can use any numbers. You could again use negative 5 and 10 if you want. Here we are going to choose negative 6 and 4.4. Is negative 6 less than 4.4? One's negative and one's positive. That's an easy question to answer. Then if I divide them both by 2, they're going to get closer to 0. They're going to cut that distance in half. But still, what was negative 6 is still less than what was 4.4. Bunger, question?
No, comment. You can never divide to get 0 unless you're dividing by 0, which really doesn't make any sense.
Exactly, yeah. We can't start with something and cut it into pieces and end up with 0. That doesn't.
Exactly.
We can subtract to get to 0, but we cannot divide. So that's where it's easy. This gets more difficult. So this one you're like, okay, this is the same as equations. It's gonna get more difficult. So let's try this one first, then we'll look at our other examples. An elephant drinks at least. What does it mean to do at least? It means to do that much or, Luke? That much or more. So that's the minimum amount. So each trunkful holds 4 liters of water. How many trunkfuls of water does the elephant drink? I like to write it in words first. So in words, he drinks 70 or more is exactly what Luke just told me. So if I think about what he's drinking, it's 70 or more. That's what at least tells me. And then each trunkful holds 4 liters, and we're going to try to solve for how many trunkfuls. So how can I set this up? Abby, do you have any? Oh, you're back late today. Do you have any ideas? So I normally try to leave the number that I know for the end because it's just a little easier to work with my variable first. And most of the time mathematicians prefer the variable to be on the left side of the equation or the inequality just because it's easier to look at. Not that it's better, but it's just a little easier. So what would be our variable? What is it that we're trying to solve for? What don't we know? Eli? What is it? No, we know how much water. It's 70 or more. We know each trunkful holds 4 liters. Cassidy? Okay.
And it's not really related. It's about a mathematician. What does it actually do for its job?
There's a lot of things a mathematician do. I am a mathematician because I have a degree in mathematics, and then my teacher licensure alongside that. So. My brother-in-law is a mathematician, but he's an accountant, so he works with money all day long. Mathematicians can do engineering, they can do architecture. There's a lot of things mathematicians can do.
So it's just someone with a math degree?
Yeah, somebody who's really good at math, and has training in math, formal training, which is like university training. Bella, what do you think? What's our unknown? How many trunkfuls? Whenever it says how many, that's what I'm trying to figure out. So I'm gonna use F just to not use T. I'm going to use F as in full trunks. How many full trunks of water did he drink? Now, that's going to get multiplied by what? 4. Because every trunk, whenever I have an every or an each trunkful holds 4 liters. So when we go to set up our inequality, he drinks through his trunk. That's how he gets water. So 4 times F, what he drinks, because 4F is what he's drinking, how should that relate to 70? What inequality symbol should be in between there? Cassidy?
Greater than or equal to.
Greater than or equal to, because it needs to be 70 or more. This amount needs to either equal 70 or be more than 70. So all of us should have that written down on our paper now. 4F is greater than or equal to 70. Now, Franny, how would I solve to get my F by itself?
Divide by 4 on both sides.
We divide by the 4 on both sides. Now 70 is a little hard to see what it is divided by 4, so make it easier. Drop down to 60. What would 60 divided by 4 be? You should be able to think this in your head. Think about minutes. 60 minutes in an hour. What's a fourth? 15. Then do 10 divided by 4, which is 2.5. So we're going to get that F is greater than or equal to 12.5. So he is completely filling his trunk with water to drink at least 12 and a half times a day.
Ow.
And actually, if you've ever watched an elephant drink, anyone know how it actually happens?
They use their nose.
Well, what can they drink out of their trunk? Luke?
Okay, so they suck up the water from their trunks and they put their trunks in their mouth.
Yeah, it's really weird. So imagine if this was your trunk. They put their trunk like a straw. They suck it up, but they cannot drink through their trunk. So then they stick their trunk in their mouth, and they essentially blow through their trunk, and they blow their water into their mouth. So it's really weird that they like. And actually, sometimes they blow it at people or blow it at other animals.
Yeah, I got to ride an elephant once, and that's what it did.
Yeah.
It was
So
when I was little, so I got
if an elephant thinks that other animals are like too hot or whatever, where they're trying to like protect each other or wash their baby, they'll use their trunks and like squirt water at you. So yeah, be cautious. Are you looking for the notes? Be cautious when you hang around elephants. I know you guys do so much hanging out with elephants. Try this. Your mouse. Now, this is what's really interesting. There is a myth that elephants are afraid of mice. And I actually, assuming we have time, either at the end of class or tomorrow, I'm going to show you the Mythbusters clip that relates to them testing, is an elephant afraid of a mouse? So, love the Mythbusters. They try everything out.
Sadly, they're
Do you know why
bending
they're
it.
afraid of mice?
We'll talk about that more later. So right now, let's focus on the math. A mouse drinks at least 42 thousandths of a liter, I mean a mouse is tiny, of water a week. Not a day. Excuse me, a week. How many liters of water does the mouse drink in one day?
On average.
On average, because it will not necessarily be the exact same, but if we know what he drinks in a week, how do we figure out what he drinks in a day? So try to figure this out on your own. You've got this. If you're watching the video, you should be trying this on your own right now. What is the unknown value? Like, what do we not know? Who can tell me? Health?
How much water are you drinking in a day?
How much water he drinks in a day. So a good variable might be D for daily water consumption. Are you still looking for the notes, Thomas? They're over here. Why did you not ask already? Why are we 10 minutes into class, 20 minutes into class, and you're just now thinking about the notes?
Some people are still not.
My apologies. If you were still math testing, I guess. They were hiding out in the bathroom or something. Some kids do that. You laugh, but some kids actually do that.
Oh, that's cool.
Not Thomas, though. He's a good kid. Thomas is like, yeah, you think. All right. Who can help me out? What inequality did we set up? I'll go to Luke, but I've already talked to him a couple times. Any other volunteers? Thomas Shree just got here.
So you divide, it's So it's D times wait.
Did you catch up and write down the one from up above? So
No.
get that one first. I think you're going to be a little confused if you try to dive right in with us.
Could I say what I think though?
No, because I already know what you're going to say. This is a week, and we're solving for D times what?
Okay, so D times 7.
Okay.
Is
I'm going to put the
less
7
than
first.
Or less than or greater, like
You're
less
close.
than or greater than or equal to.
If he drinks at least, it's got to be greater than or equal to my 0.042. Because, remember, he drinks... I could say drinks equal to or more than 0.042, which that's why I use greater than or equal to solve class.
0.006.
Well, okay, first to solve, we divide by 7.
Oh.
And then we have to put it in the inequality, so D is still greater than or equal to, what is it again, Luke?
0.006.
So this mouse drinks tenths, hundredths, thousandths in that 6th place. He drinks 6,000ths of a liter a day. But think about it like this. What else can we call 1,000th of a liter? Anyone know what that unit is called? Eminal? A milliliter. What's milli mean?
5,000.
Yeah,
Million?
well, so it's a little dangerous when we use it in different ways, but in milliliters, there's 1,000 milliliters in a liter. So if we're talking 6,000, he actually drinks greater than or equal to 6 milliliters. So you could rewrite it and say he drinks his daily consumption is greater than or equal to 6 milliliters. And actually, if you look at that and compare it to actually how big a mouse is, you might be impressed. Like, oh, wow. Because think about if you drank as much water as the size of your body, that'd be a lot of water. A mouse is really, really small, and milliliters aren't that much smaller than it. So we could compare how big's a mouse compared to those milliliters, and it would be an interesting ratio to look at. So here's where things get different. This is where you really got to pay attention to the details, because some of you keep forgetting about your negative symbols.
The multiplication
When we have an inequality that involves a negative on either side, say we have a negative 1/2 is less than 3. And what we want to do is make it positive. Like when we're trying to solve for our variable values, we're always trying to make a positive 1 variable. What I have to do on both sides is multiply by a negative, because to turn that negative value into a positive, I've got to multiply by a negative. But here's the problem. Watch what happens to both my points when I multiply by a negative 2. Here's my negative 1/2, and here's my 3. So negative 1/2 times negative 2 will go to positive 1. But 3 times a negative 2 goes down to a negative 6. So what just happened to my points and their places on the number line? My blue point started to the left, but it's going to end right here. My red point started to the right, but it's going to end down here. What has happened to the locations of blue and red?
They are not.
What do you mean changed? They
Are not where they're supposed to be.
blue started left
Oh, they reversed.
and red was on the right. When I end, blue is on the right and red is on the left. They have flipped places. They have turned around. They've kind of flip-flopped where they are because we multiplied by a negative value. So what we have to do is flip the inequality symbol. So on your notes, where you see that multiplication property of inequality, you have it off to the right there, and I'm actually going to pull up the notes so that you guys know right where to write it. Inequalities, multiplication, division. So right down here, off to the right, I want you, not giant, but pretty big. If you multiply or divide by a negative, inequality turns around. Your inequality symbol flips. It turns around. Whatever you want to say. If you multiply or divide by a negative value, your inequality symbol has to turn around. Now that doesn't mean that your numbers change where they are. My left side is still my left side. My right side is still my right side. But the symbol between them flips around. And I would either highlight, circle, star, point to, whatever you can. This symbol compared to this symbol, it turned around. It flipped. It changed the direction that it was pointing. That was less than. This is now greater than. So that's why this gets really tricky, is when you multiply or divide by a negative, you have to flip that middle symbol. Questions on that? Same thing when we divide. So I did not put the division property in your notes because it's the same exact rule, but I am going to capture it for you. So your division property, think of -8 less than -6. The same thing happens. They flip locations. My -8 was lower. Its value ends up higher. My -6 was closer to 0. It stays closer to 0 actually, but that makes it then be less. Is there any confusion on this? We're good? All right, let's try it. Now, these are a little bit harder to represent with real life situations. So for the first few, we're just going to do it numerically, just working with the numbers. So what do I need to do to get the k by itself? So in your notes, you have this right here. What needs to go in those boxes? What operations am I doing? And because of that, what happens to the inequality symbol? Oriana, we're missing you today. Katie, what do you think? What's going on with the k and what's that tell me to do? So we will, but we don't do that first. What's happening to k in the first step? It's being
Divided.
Yeah, I was talking to Katie, but yeah. Bunger jumped in. It is being divided. So Luke, since I see division, that makes me on both sides. Since I saw division, what do I have to do to undo that? Multiply. So this is multiplication right here, and this is multiplication right here. But because we're multiplying, and I want you somewhere, either off to the left or the right, notate that we're multiplying by a negative. We then have to, exactly what Katie said, is instead of using my less than symbol, we flip it, and now we're using the greater than symbol. Make sure that you put it pointing the right direction. It's very easy to accidentally point the wrong way. And then it just carries down, and k would have to be greater than -84.
Yay!
Any other questions? Try the got it on your own. Those of you playing with us at home, please do the got it on your own right now. You just need to realize when you eat, the food goes in your mouth. Hey guys, we're doing the got it at the top of the page. It's just off to the right though. Notice how there's a got it right beside what we just did. Now that we're solving equations and inequalities, we like to work vertically. So I try to leave you space vertically, but I may not leave you space left, right. So we're on this got it right now. Bayla, can you tell me what thought process you had in your head while you started solving? Yeah, we're going to divide by negative 3.8 on both sides because the first thing that you should have thought of was, well, I see multiplication. So to undo that, we divide. So absolutely correct. We divide by negative 3.8. Now, Zach, what'd you get there, man?
I got G is greater than or equal to negative 115.5.
Now, did you multiply or something? Like,
Yeah, I multiply.
you got to be careful. We need to divide. Cassidy, what'd you get when you did your 30.4 divided by negative 3.8? No, you just said greater than or less than. It can't be both. So we started greater than or equal to, but Bella,
I got G is less than or equal to negative 8.
this needs to be less than or equal to because we divided by a negative. And when you divide by the negative, you have to flip the inequality symbol. So G is going to be less than or equal to. Now the or equal to stays on it. When you flip that, it stays there. So sorry, what'd you get as your number?
Negative 8.
-8. G has to be less than or equal to -8. And you could try values. A value that's less than or equal to -8, say -10. If I plugged in a -10 for G, if I plugged in a -10 for G, negative times negative would make it positive. Would positive 38 be greater than 30.4? Yeah, it'd be true. So you can try values in that range. So if you guys are getting questions wrong on your homework, chill. If you guys are getting questions wrong on your homework, before you click the check answer button, try a number in that value. Think of what's less than or equal to -8. Well, or equal to, I could use -8 and see if that's right. But I would want to try one less than to see if my range is actually correct. That make sense? Questions? Cool. So we want to write the solution with the inequality symbol pointed the right direction. This should have said correct. Some of you guys are like, right, how it's got a point. No. Pointed the correct direction. So I want you guys to try to solve all 5 of those. We want to point the inequality symbol the correct direction when we finish it. question, please stick up a hand so I can help you with this. If you're watching the video, you should be trying this on your own. Do not just sit there and wait for us. I'm going to start flipping some of my classes, so some people will be watching the video for homework and doing the homework in class. I'm going to try with you guys probably next chapter.
You should put ads on your video.
No.
Your videos make
You elaborate.
On flipping? So this chapter I'm trying it with the other class, teaching you guys and then flipping the other class. But next chapter I think I'm going to try teaching the other class and flipping you guys, which means that instead of coming to class learning the material and going home and doing the work, you would come to class, do the work, and go home and learn the next day's stuff. So your homework would be like, watch the video, but then when you come to school, during class we would do the practice work. If you get done with all the practice, you can start the next video and like get a head start on the homework for that night. So what it means by flipping is instead of work at home, learn here, learn at home, do the work here when I can help you.
So the other, so our homework, that's usually homework.
Would be to fill out your notes and watch the video.
So the other class is gonna
That's my
do
thought.
the
Yeah,
notes,
that's my idea
and
with this
we're
chapter.
gonna do the homework.
I'm just looking for feedback. I'm trying stuff in my professional growth.
I like that.
All right, Isaiah. In our first one here, I've gone ahead and written up here everything that needed to be done because we're using inverse operations to undo multiplication or undo division. So we know we're undoing multiplication. We divide by the value in front of it. So we're dividing by -3. But what'd you get for your answer? I want you to say it correctly. A is less than -9. I divided by a negative, which made my number negative, and because I divided by the negative, I flipped my inequality. Check that you have A is less than -9 on your paper. Divine, what about my second one here? What do you have written down for that answer? Not quite. Anybody want to help out? Eli? A is greater than -9. Look at what's happening. We're multiplying by a -3 on both sides. So -3. Ooh, wait.
Wouldn't it be positive?
It is positive
That makes some more sense.
because -3 times -3 makes a +9. Now, what the multiplication by the negative does do that Eli said correctly is flip that inequality symbol. It's got to turn around. Now, what about my third one? Thomas, what do you have there?
I thought that A was greater than 9.
Now, are we multiplying or dividing by a negative?
No.
No. So do I need to flip my inequality?
Oh.
No. So it stays pointing the same direction. The only reason we flip it is if we multiplied or divided by a negative.
Did we divide
Smart.
7 by 3?
But that's a positive number. Because remember, when we divided by the positive, it just got closer to 0, but they didn't flip places. They just got closer in.
So it has to be a negative.
It has to be so what you're doing to both sides has to be negative. So what we did here used a negative. What we did here used a negative. What we did right here did not use a negative. We do not flip the inequality. Making a little bit more sense? What about my next one, Karina?
A is less than 9.
Now, do we need to flip the inequality?
Greater.
It's greater than 9. Check your inequality symbols, guys. And my last one, Brennan, what do you got? So, answer this first. Do we need to flip the inequality? No. With a division is with a positive number, so we'll still have A is less than, but we're not dividing by a negative. Look at what we're doing. Yeah, -9. It's all about what it is we are doing.
They're all 9s.
I know.
Is that what you meant to do?
Yes.
1, 2, 3, 4, 5.
Alright, so try the got it on your own. Remember what we do when we have a fraction in front of our our letter? What's the thing in front called? You're using this word in science now. Starts with a C.
The coefficient.
Coefficient. When we have a fraction as our coefficient, remember what we do. So try that on your own real fast. 1/12 b is less than or equal to 1/12. It is kind of self-explanatory. Crystal, what do you want to do on both sides? Now, you're on the right track, but because this is a fraction, remember the whole KCF thing that we used to do? So instead of dividing by the value, what is it? I gotta hear you say it. Starts with an R, starts with a re. The reciprocal. So we use the reciprocal on both sides, and we actually multiply by that. Now here's what's crazy. 12 on top and bottom cancels. 1 on top and bottom cancels. 1 on top and bottom cancels. 12 on top and bottom cancels. So wait a minute. If everything canceled, it's B is less than or equal to 1. When it all cancels, it just becomes 1. Yeah. Hold up. We got a question. Yeah.
Do we have to go through all that work? Couldn't we just see that there's 1 health on each side and
Yeah. You can. You can just see that it's on both sides and cancel. Get rid of it. Hold up. I got 2 minutes left. Where are we going? Good. If half a number is less than 100, what are the possible values? So to write that out, half a number, well, just like we had a 1/12 of a number up there, half of a number is less than 100. What would we do on both sides?
divide by
No. Multiply by 2. So that number has to be less than 200. Thank you, guys. Try your homework. Come to class tomorrow with any questions from that homework.
I think we should get those little things that are inside the air